Hello and welcome to MyScience Tutorials. In today's video, we want to look at how to solve first-order linear differential equations. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So what is a first-order linear differential equation? So if we have any equation in the form dy dx plus p of x multiplied by y is equal to q of x. Any equation that is in the form of these can be said to be what? A first order linear differential equation. First order linear differential equation. Okay. Now, one thing we need to know about first order differential equations is that always the dy dx term has to have a coefficient of 1. So if you have anything multiplying or dividing the dy dx, we need to make sure we get rid of it and just make dy dx stand alone. Now, to be able to solve a first order linear differential equation, we need something we call the integration factor. Now, the integration factor is represented by ix and is given by what? E raised to the power differential of the function p of x with respect to what? Dx. Okay, so now that if we're able to find the integration factor, we now substitute that into the formula. Y is equal to 1 over the integration factor multiplied by what? The integral of what? The integration factor ix multiplied by what? Q of x. Okay, and because we're integrating, we add c to that with respect to x. All right, so after we found our integration factor, we need to substitute it into this equation over here, and then we solve for our equation of y, and that becomes what? The answer for our first order differential equation. Now let's have a look at an example, or let's solve an example so that we see how to go around solving a differential equation. So let me quickly erase everything I have over here, erase all ink on the slide. All right, so let's start. So we have to solve the differential equation dy dx plus y on x is equal to e raised to the power negative s. All right, so this is the equation that we have. Let's look at the solution. All right, so the first thing we need to check for a first order linear differential equation is that we need to make sure what the coefficient of the dy dx term is 1. But as we can see over here, it is 1, so we are good to go. So let's quote the general equation of first order differential equation. So we have dy dx plus the function p of x multiplied by y is equal to what? Q of x. Now, if we compare this to this, we can rewrite the equation that we have over here, the question that we have been given, as what? Dy dx plus, we can make the y stand alone by doing this 1 over x multiplied by what? Y is equal to what? E raised to the power negative x. So in this case, this and this are now what? Very similar to each other. So we can now go ahead and find what our p of s is and what our q of s is. So if we compare these two equations, we get to realize the function p of x is equal to the 1 over x that we have over here. Then the function q of x is equal to what? The negative e raised to the power negative x that we have over there. So now that we have what our p of x and our q of x is, the next thing we need to do is to find the integration factor. Now, like I said, the integration factor ix is equal to e raised to the power the integral of the function p of x dx. So it means this is equal to e raised to the power the integral of what? 1 over x dx. Okay, so from here, let me draw a line here. From here, my I of x is equal to e. Now, if I integrate 1 over x dx, I get what? Ln x. Okay, now this is equal to if we have an e function and it's raised to the power, we can bring the power in front of the e function. So if we bring that here, and let me rewrite that in a more suitable way. So I'm going to write x ln e. Now, but ln e, okay, this is more like x multiplied by 1 over x. So ln is the inverse of what? E, and then e is also the inverse of ln. So they are inversely proportional. So it means if we multiply the two of them, that is going to give us 1. So it means our I of x, which is our integration factor in this case, is just equal to x. So now that we have our integration factor, let's put the function, the equation of the function that we need to put the integration factor into before we solve. So that function is equal to what? Y is equal to what? The integration factor, 1 over the integration factor, that is 1 over I of x multiplied by the integral of what? Of the integration factor multiplied by the function q of x over here, okay, dx, then plus c. That is after we are done integrating, we need to add plus c, okay. So it means from here our y is equal to 1 over the integration factor is x, so we have x multiplied by the integral of x multiplied by what? Our q of x is what? E raised to the power negative x, okay, ds. Now we need to what? Expand this or simplify this to be able to get our answer. Now one thing we need to look at is what? If you look at this side of the equation, okay, that is what? The integral of what? X e raised to the power x dx, okay. For us to be able to what? Integrate this function, we need to what? Do integration by parts. So we need to what? Do integration by parts, okay. That is how we are going to what? Simplify, or that is how we'll be able to simplify this side of the integral part of the final answer. So let's keep in mind this equation over here. So let's solve just this side using the integration by part, and then we'll come back and do the substitution. So from here we can say that the integration by part, the formula is what? The integral of what? U dv is equal to what? uv minus integral of what? V du. Okay, now if I go back, you see that this is the function that we want to integrate. So we have the function integral of what? X e raised to the power negative x dx. That is what we want to integrate. So we say let u be equal to what? The x over here, and then let dv be equal to the other part, which is what? E raised to the power negative x what? ds. So we differentiate the u. So if we differentiate the u with respect to what? With respect to x, we get the u ds is equal to, if we differentiate x, we get what? 1. Now this 1, if we cross multiply, we are going to get what? The u to be equal to what? The x. So it means we are done with this part of it. Now we have dv is equal to e raised to the power negative x dx. What we need to do is what? To integrate the differential of dv to get this v. So we integrate dv to get what? The integral of e raised to the power negative x dx. So if we integrate the differential of v, we get v to be equal to, now if we integrate an e function, okay, we get what? The same e function raised to the same power divided by the differential of the power over here. So if we differentiate the power, we put it at the bottom over here. So if we differentiate negative x, we get negative 1. So it means our v is equal to what? Negative e raised to the power negative x, okay. So now we have our v, we have our u, we have our dv, and then we have our what? Dx. So we can substitute them back into this formula. So using still on the integration by parts, so it means we have the integral of what? Now this becomes what we have over here. So the integral of what? X e negative x dx is now equal to, where is our u? Our u is x over here multiplied by v. Our v is what? Negative e raised to the power negative x, then minus the integral of, our v is still negative e raised to the power negative x our du is the dx over here, so we have ds. Okay, so from here, this is the question, this is still this, so we have negative x e raised to the power negative x minus the integral of what? Now we can bring the negative outside, so here becomes positive, then e raised to the power negative x ds. So this is equal to negative x e raised to the power negative x plus, if we integrate an e function, like I said, we repeat the function e raised to the power negative s, then we divide it by the differential of the power. If we differentiate negative s, we get negative 1. Okay, so that means we are done with this. Then we just add a constant c. So over here we have what? Negative x e raised to the power negative x. Sorry, this should be minus. Okay, so minus e raised to the power negative x plus c. If you like, you can factor negative e x raised to the power negative s out. So we have negative e raised to the power negative x into bracket. Then we have x here, then plus 1, then plus c. You can see that if we multiply this by this, we get negative s e raised to the power negative s. If we multiply negative e raised to the power negative s by 1, we get negative e raised to the power negative s. So it means integrating this, just this function, using the integration by part, this is what we get. But this is not our final answer. Remember, we have our y to be equal to what? The product of what? The integration, 1 over the integration factor, which is 1 over x over here, and then multiplied by what we just finished solving using the integration by parts. So it means our y, let me use another color to represent that. Our y is equal to, if we go back, we can see that we have 1 over x over here. So we have 1 over x multiplied by this whole function, which we've now integrated to get this. So we now multiply 1 over x by this, the whole of everything over here. So by negative e raised to the power negative x multiplied by x plus 1, then plus c. So after all, our final answer is going to be y is equal to negative 1 over x e raised to the power negative x multiplied by what? X plus 1, then plus c, as our final answer for this particular example. Alright, so let's have a look at another example. So example number 2, we have the equation x plus 1 dy dx plus what? 2y is equal to what? X plus 1 all squared. So this is the function. So this is the function, and we are to what? Solve the differential equation. So let me use a white color for that. So like I said, the first thing we need to do is to make sure the what? The dy dx term is just what? 1. The coefficient of the dy dx term is 1. So we divide both sides by x plus 1. This side by x plus 1. This side also by what? X plus 1. So this cancels this. So we have our dy dx to now be plus this becomes what? 2 on what? X plus 1 multiplied by y. This is still 2y over x plus 1, sorry, is equal to this, cancels one of these. So we have x plus 1. Then we close the bracket. Now if we look at this now looks like the general form of what? The differential equation that we've talked about. So that is what? Dy dx plus what? P of s multiplied by y to be equal to what? Q of x. So from here we can boldly say what? Our P of x to be equal to what? 2 on x plus 1. Then our Q of x is equal to what? Just x plus 1. Okay, so now that we have the value of our P of s and then our Q of s, we need to go ahead and find what? Our integration factor. Now the integration factor, like I said, is 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 equal to e raised to the power the integral of the function P of x with respect to what? X. So we have our integration factor, which is what? I of x to be equal to e integral of P of s is what? 2 on x plus 1, okay, ds. So this is going to be e integral of 2 is a constant, so we can bring it outside. Then we have what? 1 over what? S plus 1 ds. So we can rewrite this as e to integral of what? S plus 1 raised to the power negative 1 what? ds. Okay, so this is equal to e to, now if we integrate this, assuming this is just u, if we integrate, it means we add 1 to the power, and we divide by what? The new power. So if we add 1 to this and we divide this by what? Negative 1 plus 1, we are going to get, that is what? X plus 1 raised to the power 0 on 0. Okay, so because these two are multiplying, we are going to get what? 0 at the top. So we have e raised to the power 0. Now if you input e raised to the power 0 into your calculator, you are going to get 1. So it means our integration factor for this particular example is 1. So now that we have the value of our integration factor, the next thing we need to do is to quote the general equation for the differential, the general answer. Okay, the form of the answer, that is what? Y is equal to 1 over what? The integration factor multiplied by the integral of what? The integration factor multiplied by what? The function k of s, then plus c dx. Okay, so this is the general form. So from here, let's go ahead and see what we have. So let me do that on a new slide. So we are going to have y is equal to 1 over the integration factor that we found over here is 1, so we have 1 over 1. Okay, so we have 1 over 1 multiplied by the integral of what? We have over here the integration factor, which is 1, and then the function q of x. So we have over here 1 multiplied by the function q of x, which is what? X plus 1, then ds. Remember, the function q of s is what? S plus 1 over here. So it means, to simplify this, we have, this is 1 multiplied by this is still the same thing. So we have the integral of what? X plus 1 ds for this particular example. So we say y is equal to s, y is equal to the integral of what? X plus 1 dx. Now, this, to solve this particular integral, we need to use what? The method of substitution. So we say let the function that we have over here, u, be that function. So we have x plus 1. So we need to differentiate this function. If we differentiate this function, we get what? Du dx to be equal to, if we differentiate x, we get 1. If we differentiate 1, we get 0. So du dx is equal to 1. So that implies that du is equal to what? ds. Okay. So from here, it means the function y can be rewritten as what? We said let u be this. So we have y is equal to what? The integral of u. Then ds is now equal to what? Du. So we have what? Du over here. So we have y is equal to what? Now, if we integrate u has the power of 1. So if we integrate u, we have what? u1 plus 1. We add 1 to the power, and then we divide by what? 1 plus 1, which is the new power. Then we add c to it. So we have our y to be what? U squared over what? 2 plus c. But remember, earlier on we did mention, or we did make u to be equal to what? The function x plus 1. So if we substitute the u back here, we have y to be equal to what? X plus 1 squared over 2 plus c. So this is our answer, or someone may like to put it in this way. Y is equal to what? 1 over 2 multiplied by x plus 1 squared plus, so this is just x plus 1, erasure. Yeah. So y is equal to 1 on 2 x plus 1 all squared plus c. So this is our answer for solving the differential equation, this over here. So thank you so much for watching. I hope this tutorial was helpful, and if this tutorial really was helpful to you, make sure you subscribe to the channel and like the video so that the YouTube algorithm will help us reach much larger audience. Okay, so thank you once again so much for watching, and I'll see you in the next video. Bye bye.